Assalamualaikum and hi again. In this video, I will talk about solving classification problems using artificial neural networks. So we're going to look at a practical case of using this ANN that we have studied before to recognize images. In the notes, there is one chapter talking about ANN for using ANN for face detection. So you can read and study it, although this is not really a good way of solving the problem because it is not really using the information from the image properly. If you recall, in an image we have several features that we need to identify first before feeding the information to the neural network. So to summarize what has been done is this chapter 5. Assuming this is a fully connected neural network which we have studied before, maybe call it dense network. So let's say that we want to use this densely connected network for image classification. What this means is that we are going to take the two-dimensional image. So we have a two-dimensional image. So we have this image structure, and we want what has been done in the module is that the 2D image is collapsed down into a 1D vector and fed through the dense ANN. Although it's a different ANN, in chapter 5 the idea was to use radial basis function neural network, but that's basically how my former student did it. He just collapsed the two-dimensional image into a one-dimensional vector and fed through the dense artificial neural network, which is an RBF. So you can see that the original two-dimensional spatial structure of the image has been lost, and additionally we're going to have a huge amount of parameters in this network because we are using a dense structure, which means we are connecting every single pixel in our input to every single neuron in the hidden layer. Although it's a different ANN, which is, like I said, RBF, but it's still causing a lot of parameters. So this is not really feasible in practice, although it works. If you look at the module, so the RBF use has 13,332 inputs, corresponding to, this is the image size, 132 times 101 pixels. So this is a very huge amount of input, and it doesn't exploit the spatial structure of the image. So this is not a good way to do it, although it works, but really the amount of image that has been used and the data is very small, so it works in this way. So traditionally, how people do it is to extract features, which I will explain using this slide. So this slide has been uploaded in the e-learning. I won't talk all about, just highlighting a few points. So traditionally, how people do image classification is to extract features, and this feature data that is being fed through the neural network. This is how we do it traditionally. So we will get into a convolutional neural network, which is a deep learning structure where the raw image data will be fed to the CNN later on. But just to have a look at the traditional way. So this is a system that has been around for like more than 10 years, if I'm not mistaken. It has been developed at Cairo, the Center of Artificial Intelligence and Robotics in UTM. The idea of this system is to recognize from the picture of the cross-sectional area of the wood, we know what type of wood it will be. So we can identify what kind of wood. So why we need to do this? There are several reasons as explained here. Okay, we want to ensure that we are using the correct type of wood for example, for roof truss you need to have woods with acceptable strength. Okay, so there are many reasons for that. So how do they do it? The idea is to look at, this is traditional way, manual, using a human expert looking through a lens, and he can tell what type of wood it is. But we can take pictures of cross-sectional area of the wood, and we can see that different wood types will give you different pictures. So the process is as follows. You would need to have the image, okay, of the wood cross-sectional area, and you do some pre-processing. I just would like to highlight the pre-processing part here. So these are the equipment used. This is the actual image obtained. These are grayscale images. You can see different types of wood will result in a different images. So from the wood structure, there is, because the idea is the cross-sectional area of the wood would have different texture, and it's observable from the image. So one method that is suitable to analyze these different types of texture is GLCM. So what it does is, just by looking at the values of the gray level, so when you have a gray level image, each pixel value will go from 0 to 255, from light to dark, or vice versa, and from these different values you can obtain this GLCM. Okay, that's the procedure, which you are not responsible, just to know how the texture analysis has been done, i.e. obtaining the feature from the image. So from the image we apply GLCM, and then we obtain these values: angular, second moment, contrast, and so on. As you will see, we will have different feature values, and in the end 20 feature values from one image pattern are being obtained. So as you can see, instead of the raw image values obtained from the original image, we extract the features, and this becomes the input of the ANN. So imagine an ANN, which is a dense structure with 20 inputs, and we define the target output for different types of wood. Okay, so here it's using just 0 and 1 to indicate different types of wood. Okay, so using an impact propagation neural network training, and so on. So that's how we implement the classification problem. So I will illustrate how in practice we do it using the TensorFlow in the next video. So thank you very much.